Yes, this presentation was originally done last year's conference. I've got a few things that are a little bit different on it, but it's pretty much the same thing. I wanted to do this on capacitors because it's in audio. It's one of the big things that's talked about out on the internet, and you go to a hi-fi store and talk to people. There's always a conversation about capacitors. Now, this one starts out saying capacitors in general, but it gets going and really talks about filmed capacitors for the most part. So if everybody can see the screen here, the first thing would be that says there's audio capacitors, improvements over time. We've used capacitors in our radios and other audio equipment for a long time. 70 to 90 years is what I said, but you can go back quite a ways with this. The early developments were hit and miss, but they then became usable and stable, and they worked just fine. The issue with the audio is that it improved over time, and that you could hear differences with different equipment depending on the quality level of the capacitor. So you could make a case for saying, it's just not good enough. We got to do better. So in the last 60 years, there's been improvements in hi-fi, usually through transformers, circuit designs, and then the different devices get improved. What really needed to be improved were the types of capacitors. We needed to find different ways to make them. We wanted to find better dielectrics, because that was an important finding as they developed the first grouping of capacitors. And it also needed to have more consistent fabrication techniques, which is another important thing for manufacturers. Coupling capacitors. This is where we're going to talk about the type of capacitor that's not really an electrolytic. These are used they're almost all equipment has them, particularly our audio equipment, where they pass an AC signal from one section of the device to the next section, but they block any DC from coupling through. That's the description of a coupling capacitor, and the better that it blocks DC and the better that it passes an AC signal, the better it's going to sound. The remaining slides are discussing coupling capacitors. Right here on this schematic, which I'm assuming most of you are good at schematics, a basic Dynaco Mark III amplifier, and I've circled in blue where the coupling capacitors are. To the left of it is the phase splitting section, where they got a voltage amplifier and then a phase splitter. And then it passes the signal through the coupling capacitor to the grids of the output tubes. Now that's this hi-fi amplifier, and it has just two coupling capacitors. That's simple, and in my case, I really like that idea. It's simple. We go to another amplifier like the Macintosh MC60, was built around the same time as the Dynaco Mark IIIs, and I've circled them here. There's actually 5 in this particular amplifier. So every time you wanted to replace these coupling capacitors, you had to do 5 in an MC60, where you only had to do 2 in the Mark III. There are lots of other capacitors in these devices. Most of them are in the power supply. Some of them are feedback caps. But these are the coupling capacitors that do the main work of passing the audio signal through from one section to the next. All right, early capacitors, I'm saying early is before World War II. Sprague developed a paper and oil capacitor known as the vitamin Q. These were hermetically sealed and have excellent long-term durability. The hermetically sealing of the capacitor is a big deal. If you design that capacitor correctly and then you seal it properly, You don't get moisture in it. You don't get it doesn't get contaminants in it. It doesn't dry out. It's very good. The Russians liked it so much that they built two different ones, the K40Y9 and the K42Y2, and they're actually desirable as well. You can still buy those if you know where to go on the internet to find them. And they're not identical to the Sprague version, but they're very similar idea, similar hermetic sealing, and that's really good. So then what happens is most of the other designs that were used back in that era were not really the greatest ones and really should be removed when we're restoring our vintage equipment. Most of these were film capacitors, and the most important development was to improve film types. A film type is usually made by excuse me, using a non-conductive sheet of dielectric film, then adding a conductive layer over on both sides. Many are cut into strips, which are then rolled up. A coating is added to the outside, leads are installed on each end, and almost every manufacturer today makes a film capacitor with a similar type of arrangement. Some of them have improved technologies a little bit, make it easier to do this, but they're very similar in how they do it. They make them for all different voltages, ratings, and also there's a lot of different costs with these. And almost all new equipment will have these types of film capacitors. Now, film capacitor types, there's basically a couple of different ones. One is called film and foil, and it's usually a layer of foil, like aluminum, tin, whatever, and it's laid over the dielectric film. These have a higher current rating property than this other type. And then this other one is one that's gotten a lot of press lately, is metallized film. And what this is a layer of vacuum deposited metal is sprayed over the dielectric film. They have a larger capacitance and a smaller case size. They're easier and less costly to make. You'll see these designations when you look through capacitor information or read stuff on the internet. If you find something that's labeled PP, it's a generic designation for polypropylene. MKP is metallized, which is that sprayed on over the polypropylene. FKP is foil. So here's the foil. It's not sprayed on. It's a sheet of foil with polypropylene. PS is polystyrene with foil. And PTFE is Teflon with foil. So those generic number letters on the left are very common that you'll see in all of the, not all the literature, but quite a bit of it. All right, dielectric absorption. And this is kind of what they figured out back in that era was important. Dielectric absorption is the name given to the effect by which a capacitor that has been charged for a long time discharges only incompletely when briefly discharged. Okay, so what that basically is saying is that the capacitor, no matter what you use, isn't perfect. It basically will hold on to a charge to some extent. Now that doesn't do much for your DC blocking, but it will make it so that when you're dealing with AC signals going through it, this is not good. It's not perfect. If it was perfect, it would have no memory of whatever the last signal was as you're trying to put the next signal through it. So you want this dielectric absorption to be, the very best you can get. Film types are low, electrolytics much higher. The lower the better for sound quality. Here's a chart that shows some of those types that we had and what the actual absorption values are. And it's shown in percentage, and I haven't been able to determine exactly how they test these to get it a percent. But this is a fairly normal looking chart that I find in several places, where the polypropylenes are 0.05 to 0.1%, which sounds pretty low. The Teflons are even lower. The polystyrenes are low. But then the polyesters, which you're going to be able to find polyester capacitors a lot, they're 2 to 5 times higher than these other materials. And the aluminum electrolytics are really bad. So it's not good to use electrolytics as a coupling capacitor for sure. All right, dielectric materials. Polyester is low cost. So low cost is good for a lot of people. So therefore you can make them. They're easy to use. They're not the best sound quality, but they are useful for other equipment, not amplifying the audio signal. So some radio, some TV, there is places for polyester. It's just not considered to be a good product for audio. So that leaves us polypropylene, polystyrene, and Teflon were found to have better sonic characteristics. And these are the preferred materials used for hi-fi today. Polystyrene. This was a material that was easy to use and had very nice sound qualities. It's very useful for small picofarad size values of capacitor. Very few are available in the larger sizes. And its one big drawback is its limited upper temperature range of 150 degrees F. In well-ventilated equipment, it's not a problem, but some people don't like to use them because they think that it's going to be put in a hot environment, and they will melt if you get them really hot. So that's not a good thing. But I do like them, and I think they sound very nice. Teflon. This is a really good material and considered the best sounding of the dielectric materials. It's a little more difficult to use than the polypropylenes and the polystyrenes, but its biggest concern is its cost. It costs more to buy it, use it, and make good capacitors with it. But when you're using it in the very highest end equipment, its cost is not that big of a concern. Polypropylene. This has become the most popular material due to excellent properties, lower cost, and ease of manufacturing. Most of the coupling caps in high-end audio today are the MKP metallized polypropylene. They can be made very cheaply, very easily, or they can be really intricately made and cost a lot more money. Conductive materials. So when you're looking at the film type, you're going to see some different materials. And aluminum is probably the most used. Maybe the tin is almost the same. But then they continue to go up to copper, silver, and gold. And you can picture that the cost of each of those goes higher and higher as we go further down this list. Excuse me. This is not the spray down material. These are usually just the aluminum, or this is just the foil type and the FKP type capacitors. Okay, over time, the polypropylenes, Teflons, and polystyrenes were developed in the late 60s. So what happened was we had a lot of our equipment built before the late 60s. There was much of it before World War II, and then some of it after World War II, where we had some nice hi-fi equipment put in place. But what was happening is they weren't using these newer materials for the capacitors. They were using older technology, stable, durable, but not today's better equipment. The newer equipment, or some of the newer designs, really are better. They have some low-cost ones. They got some high-cost ones. The high-cost ones are really proprietary in nature. You really can't find an awful lot out about how their manufacturing process goes. If you did find if you had some equipment from 1970s, you may have found that you did have some of the better quality material in there, but most of us don't have that. So a lot of us have some really, what we think are really nice old amps, but they don't have the best capacitors in them. And when you go to restore them, you really should give that some thought. Cost and benefit. Excuse me here. The value of a coupling capacitor can vary quite a bit. The electronics industry needed good quality but low cost for almost every item. In the world of hi-fi, they wanted good quality, but higher cost was tolerated depending on the cost of the equipment. Each manufacturer's product is designed for a price point to compete with others. Vendors produce a data sheet for each of their items. It's available online on their website or at the distributor's site. Contains all the specifications and test info, has IEEE standards, has test values, so that you could look all this stuff and compare with other manufacturers. There's a typical data sheet. It's hard to read, but you can blow that up if you wanted to get this. I'll send it to anybody that wants it. You can blow it up and look. But most of the vendors will have a data sheet that looks very similar. You can see the picture of it. It's got a whole listing of specifications and then what the values are of the specification that they expect to meet. Maybe a picture of it with some lead links and other things. This is a very common data sheet, but at least you can take this one and compare it with somebody else's data sheet to see what the differences are between the designs. All right, I'm going to have another 6 slides coming up. And what I did is I said it's very common to have a 0.22 microfarad capacitor at 600 volts. So I'm going to look through a bunch of places where they were sold. And these capacitors are both in the Dynaco and the Macintosh amps that I showed earlier. It's also pretty common size for other amplifiers that from different manufacturers that might use 0.05s or 0.1 microfarads. But the value of the cost of the capacitor would be very similar between all three. I'm going to put in higher voltage rated caps simply because they're in our vacuum tube equipment. Some of the solid state equipment has lower voltage requirements, but I chose the higher voltage ones simply because most of us will be replacing our equipment with 600 volts or so on our audio equipment. So let's look at what some of the manufacturers are selling. Most of you are familiar with Mauser, and if you go there, they're selling 2 different manufacturers. The CDE makes a 940 and an Illinois, and you'll notice the pricing is similar, but it is different. Viget has 2 different MKPs. So again, the MKPs are the metallized polypropylene. One is $8, the other is $2. I mean, there's quite a bit of difference. Even though they're both MKPs, they're different in cost. And this is where you'd have to have those data sheets to compare why is one different than the other and what's it used for? What's it designed for? There's some other vendor costs. Just Radios is a place up in Canada, and they're very good to work with. They have JFX premiums for $2.50 or so, and AuraCap. And AuraCap is a very highly rated cap for $7. Parts Express is another major vendor. They've got the Janssen Z Superiors for $11.50 and the Z Silvers. Here we go with the silver cost of $20.96. Now again, these are all for just one capacitor. All these numbers. Audyne is a very highly rated manufacturer. They've got copper, $62 for the same 0.22 microfarad. And then they've got an Audyne makes a Cap Plus for almost $9. Solon, who's noted for having some low-cost ones, makes a silver one for $22. Michael Percy is up in Maine. He sells a lot of high-end and medium-level parts, and he sells the audio cap Teflon type for $102, the PCU film and foil for $66. Then audio cap also makes some multi-cap versions for $17 and $8, and the audio cap RT is a polystyrene and tinfoil for $13. So these prices get to be all over the place. Haviland Super Caps from Michael Percy at $32. The Solon basic ones for $2. And Jupiter Aluminum and Beeswax. Now, Beeswax, excuse me, I'm not even sure where they put that. But again, it's the manufacturers say this is important. You get $42. Parts Connection is another major vendor. The Aura Caps at $16, Mundorf at $6, Clarity Caps, CSAs at $15, Stealth Cap, $109, Clarity Cap CMR, $38, and Obligado Ultra. Obligado is a Chinese company that makes nice quality products, but that one's Chinese all by itself, not even some American or European brand. It's just a Chinese brand. And more Parts Connections with some of the better Mundorf products. Once you get to the Mundorf Supremes, they start, that whole line gets pretty expensive. Silver and gold, $71, $43, $53, and Audyne silver, $106. So we're looking at what is really a huge variation in pricing. So how do you make heads or tails of any of this? So there's a place on the internet, and I've listed here some of the references are in the at the end of the program here, where you could go to a place called Homemade Hi-Fi. And what he has done is he's taken a whole bunch of capacitors, listened to, put them in his equipment, listened to them, and made comparisons between models. And he's got a chart showing the ranking of all this. Again, it's his opinion, and not surprisingly, there's a correlation of better sound with higher cost. In other words, the most expensive ones will be rated higher than the lower ones. Now, I don't know about stuff like that, because whenever you go to these sites, somebody is making an opinion. Now, where did he get his opinion from? Was it somebody who paid him, or did he do it only because he felt like doing it? It's hard to say. But there is a correlation between better sound with higher cost. One of the things that we really need to be doing is we've got to figure out what we're going to buy. But we have to purchase caps with qualities that enhance our equipment. If you have a very bright amp and speaker system, then some paper and oil type coupling caps may smooth it out. The paper and oil types tend to be not as linear frequency across the board from top to bottom, but they have a very nice, smooth mid-range sound. So if your system is very bright, these can really help offset some of that when you put these in your coupling cabinet positions. You could buy some higher level MKPs, which will then brighten up an amp and speaker system that needs more detail or brightening. I said amp and speaker system because the speaker systems almost always have crossovers, and the crossovers have capacitors in there that you could look at them as coupling capacitors, where they have to pass the signal through, and they're part of a filter to pass the higher frequencies onto the tweeter section. So, it depends on what you're trying to do with it, and you really have to spend some time and effort to evaluate your own equipment and then evaluate what is available in the marketplace to make sure you bought the right capacitors to help make your system sound better. So this is the part that I have a lot of people talk to me and say, these capacitors aren't worth spending money. Okay, I get it. But why are they available? And how could somebody really want them? So let's look at it in terms of restoring or fixing some vintage equipment. Not brand new equipment, but some vintage equipment. There's no need to purchase some Odine True Silver, 4 of them at $106 for a pair of amps that would cost about $1,400. Now, I took those numbers in there because basically a pair of Dynaco Mark IIIs would use 2 in one amp and 2 in another. So there's your 4. And if it was a completely restored amp, you could get maybe $1,400 for it. Why would you spend $427 on amplifiers that only cost, that you could sell for about $1,400? That is overspending on the capacitors. At the same time, you don't want to go in there and buy $2 ones, so your total cost is $8 because you've restored the entire amplifier and they're worth $1,400. But if you've only spent $8 on capacitors, you probably aren't getting your money's worth. Or if somebody else is going to buy it, they're going to look at it and go, those capacitors aren't going to be good enough. You really should have spent more money. So you really kind of have to blend the value of your product with how much money you want to spend on capacitors. Budget's always a concern when we do a restoration. But if you can afford a bit more expensive caps, it should be worth it, particularly for your own systems. Each type has a sonic footprint. It will have a certain sound. It'll make a certain tone. And matching the values with the remaining system strengths or weaknesses is an interesting and fun effort. I've enjoyed it a lot, trying to buy different caps and put them in and see what they sound like. You have to search online for different types and impressions of their characteristics, and enjoy the hobby. So that was really my run through on all of those. That's my references. The one quote that I had came from Wikipedia on dielectric absorption. Those other sites are where you can go and buy the capacitors from. And that humble homemade hi-fi is at the bottom, where you could go and find the place and look up the ratings of all these different cabs. Now, since this was put together, I've had some comments and done some other work on capacitors. And one of the things that was presented was that there were other types of low dielectric absorption materials that were developed in the 60s, other than the polypropylene, polystyrene, and Teflon. Why aren't they used? And the easy answer to that rests more in what happens from the manufacturers. A manufacturer may find that a different type of dielectric material is either more difficult to work with, more difficult to source, or just doesn't work out in terms of stability or something. So what he does is he tries it, and if it doesn't work out, he doesn't keep making them. The industry basically would say, well, it's not worth it. We're not going that way. So the bottom line is anything else that has a good dielectric absorption, if it's not one of those three right now, it's already been put through the ringer by the manufacturers, and they've rejected it because they just couldn't deal with it, or they couldn't market it, or maybe it was just really expensive. So that was really the one thing that came out of last fall's discussion. Another one that's come about recently is an argument, not an argument, a disagreement with some of the work that I've done with these, because I like using polystyrene for feedback capacity. And was told, no, that's not good. We really need to use like ceramic NPO, modern ceramic capacitors. Well, that is a little bit more tricky. The NPOs really are excellent in terms of not changing values. They can be put in a very hot environment. Yeah, there's some real value to them, but it is still a ceramic capacitor. And you'll notice that what's used by the manufacturers and in the industry is not ceramic. They are not put in as coupling capacitors. They're not put in the key positions in our audio equipment. They may be useful for other areas or other things like telecommunication equipment, but they're not usually put in any kind of hi-fi equipment because people just say they just don't sound as good. Ceramic capacitors in general. So then they get into an argument of, well, NPOs sound better than regular ceramics. Well, okay, I'm going to stay out of that argument. I'm going to bring it up as something that maybe we should be looking more carefully into. But in general, you don't find it. And if it's not in the mainstream audio out there on the internet, they're just going to get left behind. So those are the two items that have come up that I didn't cover last fall. That's the basic show. I want to make mention of something about costs and listening. There are people that will say, why would I spend $50 on a capacitor? I can't hear that in my system. And my usual comment is a couple of things. One is you haven't spent enough money on your system so that you have a really high-end system to justify spending a lot of money on a capacitor. And as we get older, obviously, our hearing isn't as good as it used to be when we were younger. But the hearing portion aside, in order to really take advantage of higher cost capacitors, we really need to be looking at it in terms of high-end equipment. If you have a nice sounding system, that's great. But one of the things you're going to want to do someday is go to a real high-end audio store and ask them to play their best system. And if you do, you're going to come out of it going, wow, it sounds really good. Then you ask them what the total cost of that system is, and you're going to go, oh, okay, that's way more than I want to spend. Those are the systems that can really benefit from high-end capacitors that cost more. I'm personally am not going to spend that kind of money, so I try to make sure I tailor my expenditures for my capacitors in line with the values that I have in my system. And I have 6 systems set up in my house. So and I don't have the $2 ones, but I don't have the $50 ones either. So I've got a whole anything from, $6 to $18 is what I've been spending. And there is a difference. There is a difference, even on my systems. So there's my presentation.